Hello everyone and welcome to the Serverless series. When you want to get something out of the door quickly without having to be concerned with issues like maintenance, scaling and so on, Serverless is a great option. The mindset is key for Serverless journey. We will discuss them in this series. We will create APIs using Lambda, API gateway, serverless databases like DynamoDB and protect them with Lambda authorizers and Cognito authorizer. Furthermore, we will look at how we may leverage CloudFront, web application firewall, and all of these services and deploy them using ISE and Serverless Framework version 3. What sets these videos apart from the others? Here, we won't just be concerned with getting things done, we'll also consider why and how while adhering to the production level practices. We will learn some of the best coding practices, the optimization that can be done, and so on in this series. You will go from zero to hero, and I'm eager to start you all on the path towards serverless. So without wasting any bit, let's get started. So in this episode, we will look at how we can build REST APIs along with API gateway. In this and the next episode, we will be building APIs along with authorizers, communicating with a DynamoDB. In this episode, we will focus only on the API gateway and the 3 Lambda function that is outlined here. We will get this deployed and ensure we have the right foundation to move to the next episode where we integrate DynamoDB. So first, we need to ensure we have the serverless CLI installed. In order to install serverless CLI, you can issue a command called npm install-g serverless. We will be using the latest version of serverless that is available out there. I have this already installed and I have the version 3.21.0 on my system. Once you have the serverless CLI installed, create a directory to hold your serverless code. I will create a directory with name task-api. Let's go inside the directory and issue a command called serverless create along with the template. Either you can give command like serverless create -t along with the template, or you can use a shorthand for serverless and use SLS. Okay, so I will use SLS since it's easier. SLS create -t aws-node.js. So -t indicates template and we will be using the node.js template that is available out there. Click enter and this will set up your project. So let's give it a minute. Okay, it was pretty fast. So we have this project created. We can open this project in our favorite code editor. In my case, it happens to be Visual Studio Code. Okay, so I have Visual Studio Code open here. So the first thing what we will do here is clean up the comments. Okay, so I will clean up few of these comments. Okay, this all things are not needed, so let's have it lean. Okay, I will just keep these functions out here so that I can explain what is happening. If you notice here, we are indicating to the serverless framework that we are using AWS as a provider. Serverless framework provides an abstraction to different cloud providers like AWS, Azure, Google Cloud, OpenWhisk, and so on. So we will be using AWS in this series. Along with this, you can specify runtime. The runtime could be Node.js, it could be Java, Golang, and so on. We will be using Node.js 16.x for this series. The next important part is the function. This is related to the AWS Lambda. What this indicates is we have a function with name hello, and the code or the implementation for this function is supplied by the handler, which is present in the file called handler.js, and the exported method is hello. So if you notice here, I have handler.js. So this handler refers to the first part here, and the second part hello refers to the exported function within this handler file. So if I open this handler file, you will notice that we have module.exports.hello along with an async function which returns a response with status code 200 and a JSON response with message and the input that is supplied to this function. Okay, so this hello is referred here. Okay, so what I will do is I will clean up this handler file, and also I will remove the functions from here. We will start lean and we will apply all the good coding practices as we move ahead. So the first thing what I always do is create a folder called src. Okay, within src create a folder to hold the handler files that we will reference for our function. At the same time, let's also create a folder called resources. These resources will hold the CloudFormation code for all the AWS resources that we will be creating in this series. All right, so as we saw in this diagram, we will be creating 3 APIs: get task, create task, and update task, and all of this will be routed through an API gateway. We will look at authorizers and DynamoDB integration in the upcoming episodes. Okay, so let us now create these 3 functions. So first thing what we will do is let's create a file called getTask.js. The other function that we had is create task, and the third one was update task. Okay, so I have the files created here, and within these files we need to export our handler method that we saw some time back. So what we will do is we will create module dot exports dot handler. We can have a async function, but at the moment, since we'll not be using any awaits etc., we can avoid it. So this function will take in event, context, and callback as an argument. We will see this as we go along, and within this method we need to return in a specific format. Either we can do return status code, let's say This is create, so 201, and body. In body, we could do something like json.stringify, and we could pass in some kind of a message. Let's say task was created successfully. Okay, so that's it. This is one way to do. The other way is we can return using this callback method, and I prefer doing this. So instead of doing this return, what you could do is replace it with callback. The first argument is null, and the second argument is just this same object that we would return in case of a return statement. Okay, so we have this created. Similarly, what we will do is let's copy and paste this into our other methods. Let's just change the status code. Since this is get task, we will make it 200, and let's assume for now I just return an empty array. Similarly, let's do it for update task, and we will say task was updated successfully. Now, one thing to note here is when we want to update something, we would pass some kind of an identifier through our API URL, right? So we will need to capture it and use it within our function. So how do we do that? We will look into it in a few minutes. Now we have these 3 tasks or 3 functions created. We need to refer them in serverless.yml file so that the serverless framework knows what to do with those functions. So before we go ahead and declare them under functions, let us see few of the properties that we need to supply in provider. The first option is stage. When you develop something, you will want it to be deployed onto your dev environment, test environment, production, and so on. We refer them to stage. Now, the serverless framework allows you to supply options as part of the CLI command. Those options or arguments can be captured in the serverless YML file so that the same code is extensible and parameterized. Now let's say I could just have a stage as dev, but what this would do is it would not allow me to deploy this to different environments with different settings, like different stage property. So in order to have that flexibility, what we will rather do is we will use this $sign along with the curly braces, refer to the CLI options or CLI arguments with OPT colon, which says that look it to opt. Okay. So OPT, we will refer to the CLI argument, that is stage. If this is not supplied, we will use a default value of dev. Similarly, we can do it for region. If the region is supplied in the CLI argument, we use it. Else, we use a default of AP South 1, which is the Mumbai region. In addition to this, we will also specify the memory size. The minimum is 128 MB, so we will use 128 MB. Based on your function requirements, you can override the memory required as part of the function declaration. And the last property that I would be using is log retention in days. I will set this to 1 since this is just for the dev purpose. We would be not inclined towards storing these logs for large number of days. So we will use 1 day for now. All right. Now, since we have provided all the required stuff, what we will do is we will go ahead and declare this function. Okay. So first we need to give a logical name for our function. So we will give it like get task. Within this, we need to specify handler and the path towards our file. Handlers slash, the file name is create task. Oh, sorry, we are looking at get task. So the file name is get tasks and the exported method is handler. Now, since we want this to be available as an API, as a REST API, we need to provide something known as events. So we need to define the event as HTTP API. There are various events that can be used like schedule, cron, etc. But for now, we want to develop a HTTP API. So we will give the events as HTTP API. The HTTP API takes in key as path, which is the URL. We would want it to be /tasks and the method to be get for a get task API. Similarly, we will replicate this for our create and update task function. Okay, so the next is create task. The name of the file is create task. The path should be /task and the method should be post. Similarly, we will go ahead and replicate this for update task. Okay, the file name is update task.handler /tasks. It should be /task / the ID. If I just put /task /ID, this becomes a static path. But our requirement is that this ID needs to be dynamic. So in order to make this ID dynamic, we need to place it within open curly bracket and close curly bracket in this manner. Okay, so now I have all the 3 functions defined here. What we will do is go to the update task method and grab this ID that is passed as part of the URL. In order to do that, what we can do is grab that ID as part of the event.path parameters object.id. Now this ID refers to the variable that we have defined within this bracket. If this was name, then I would reference it as event.pathParameters.name. Now, since in our example we are using ID, I will be using .id. All right. So the next thing is, let's just use this ID in our message so that we know it's working properly. So we'll take this ID and refer here, and that's it. Okay. Similarly, what we could do is a create task is expected to take some kind of a body, right? So in order to get a body, what we can do is we can grab it from event.body. From this event, we can take this body. Now this body is in a stringified fashion. So we need to convert it into a JSON object, and we can do it using json.parse event.body. Now this data will be in a JSON object format, and what we can do is we can also return this data as part of our response. All right, so I have my 3 functions that are ready. So let's go ahead and deploy the same. So before deployment, we need to ensure that we have the credentials configured. So you can go to the serverless.com website, and under the getting started, go to AWS credentials. There are detailed steps that are outlined which suggests creating an IAM user which is programmatic based with the permissions needed, and as a result of that, AWS will provide us client ID and client secret. Those client ID and client secret needs to be configured using this serverless config credentials command. So grab this command, replace the key and secret with the one you receive from AWS as part of the IAM creation flow, and once you have this step done, you can go to your VS Code, open the integrated terminal, and provide SLS deploy command. Okay, so press enter. So what this will do is it will try to create the cloud formation and so on. Okay, now since it is giving an error, what we can try to do is let's delete it again. It happens sometimes. Let's just give SLS remove. It should not work since we don't have anything, but let's just ensure that I don't have any previous traces with the same name. All right, so what we will do is give SLS deploy command again. Okay, it's taking time, so seems like it will go ahead this time. So if you notice here, it creates a cloud formation template based on the serverless YML file. It has zipped our code content. So we will see in our further videos on how we can optimize the size of this zip, the functions, etc. But for now, let's keep it simple. If you notice, it is creating a cloud formation stack. It will upload this to the S3 bucket, and it will create the necessary resources, that is API gateway and Lambda functions. So what we will do is let's go to our AWS console. Let's open the cloud formation from the services. You can go to services and search for cloud formation. Open the cloud formation dashboard, and you see there is a stack name task-api-dev. Task-api was our serverless service name, as you can see here, and dev was our stage. We discussed that if we don't supply stage as part of the CLI command, then it will take the default value of dev as specified here. Okay, so let's go back to our dashboard. if you click on it, you will see that it's creating different resources as part of the deploy, like create task, Lambda function, get task, HTTP API, and so on. In order to check this out, what you could do is open Lambda from the services. As you can see, there are 3 Lambda functions that are created: task-api-dev-create task. This, the last section, was the logical name that we specified in our serverless YML file. So 3 functions we defined. There are 3 Lambda functions that has been created. Similarly, we can go to the API gateway and look at the resources that are created. So dev-task-api, and if you go to routes, you will see we have post, get, and ID, that is task/id, which is a put. Okay, if we see here, it doesn't have any authorizer that is linked. Similarly, if we go back to our Lambda function, and if you open any of our Lambda function, you will notice that the events to this Lambda function will be received from the API gateway. So when we hit the URL, it will go to the API gateway, and the API gateway will route it to the function that is being defined. All right, so let's go back to our Visual Studio Code, and as you can see here, we have the 3 endpoints for our APIs, right? So let us try this out and see it works as expected. So either you can use Postman in order to fire and execute REST APIs. I prefer using the HTTP client within VS Code so that I don't have to use any heavy REST clients outside of what I am already using. Okay, so I'm using REST client, and I have already made a video on this, on how to set it up. So I will reference it as part of this video, as also mention it in the description. Okay, so basically you just need a client called HTTP client. Okay, so it is this client, REST client, that is supplied here. Have this installed, and once this is installed, what I will do is I will create a file called api.http. all right, so first I will declare a variable called host in order to hold our URL. So the URL is this, so I'll copy it here, and in order to execute a get call, get host /task. All right, so let's click on send request, and as you can see, we have received the response from our API that is deployed. Similarly, let's look and try out the create task API. So host/task, since it's a post request, we can supply an input or the request body. The request body is of type application JSON, and let's say I have ID 1, title my first task, and description as I am enjoying my task. Okay, click on send request, and you can see the received response is 201 created, and the body is what we declared, right? We had a message as well as we had a data, that is the input, which we were sending in the response as well. Great. Similarly, let us look into the put call. Okay. For put, you can do put post / task / it would take an ID. And what we will do is I'll just, as of now, since we are not doing any special validations or anything, I'll just copy this and I'll click on send request. And as you can see, task 1 was updated successfully. Similarly, if this was 10 and if I do send, task 10 was updated successfully. So basically we have our APIs ready and deployed using serverless framework. The last thing that I want to mention as part of this episode is the logs. What happens is when it deploys, all the execution logs are sent to CloudWatch. So you can go to your AWS console, go to the Lambda where you have different functions. Okay, you can open your function for which you want to see the logs, and when you scroll down, you will see the code here, as well as under monitor you will see the metrics. Okay, sometimes the metrics takes time to populate, so you can have a look. You will be able to know how many invocations are done, what is the success rate, what is the duration, etc. In order to watch the logs, you can go to logs and there will be logs that are defined. So we executed the update API twice, so there are 2 logs here. If you expand it, you will also see any of the console logs that we made. At the moment we did not have any console logs, so nothing is printed. But the most important thing that you will notice here is the section which indicates what was the build duration and what was the memory used. So the other option that you could do is go to CloudWatch, go to log groups. Okay. Under the log groups, you can go to your respective function. Let's say update task. You see the log stream. If you want, you can refresh, open the log stream, and here you will see multiple invocations already. Start, end, start, end. So we had made 2 API calls. So let's look at the first one. If you notice, we have duration, we have build duration, memory size, max memory used, and init duration. This init duration is the cold start time. So it took around 164 milliseconds to deploy our API as part of the invocation, right? It is basically the time it took to warm our APIs. Okay. If you make a subsequent call quickly, there won't be any cold start, as you can notice in the second call that we made, wherein you don't see the init duration because there was no cold start that was present. All right, so that's all I wanted to share as part of this episode 1, where we saw how we can use serverless framework in order to deploy REST APIs, that is Lambda along with API gateway. In the next episode, we will look into integration with DynamoDB. So until then, happy learning and see you.